Hello students, in this video we'll discuss present values and accumulated values of annuities due and annuities immediate. So let's define the terminology. So what is an annuity due? That is one that is very natural. An annuity due is a stream of payments starting at time 0. Okay. And so this stream of payments looks like this. So here's our annuity due. Here's time 0, here's time 1, here's time 2, here's time 3, here's time n-1, and here's time n. The annuity due, the payments start at time 0. So the first thing you're going to get over here is you're going to have a 1, a 1, a 1, a 1, all the way down to n-1, and that's when the payments stop at time n-1. So let's compute the present value of this thing. So the present value of an annuity due is represented like this. A double dot, n is the number of years, and I is the effective annual rate of interest. Well, you're going to get what? You're going to get a 1, because that is exactly what you have at time 0. You get a 1 at time 0. Then you have this 1 at time 1, so I'm going to bring that back with new. Then I'm going to have a new squared all the way down to new to the power n-1. This is a geometric series, and I can use the geometric series formula to write this as 1 minus new, that's the common ratio, to 1 more than the last power. So 1 more than n-1 is n, and then I divide this by a 1 minus new over here, and that is our formula. Now we can simplify this. I don't like seeing that 1 minus new in the denominator, so we use the relationship. That's where 1 minus new is. So let's simplify this. So note that 1 over 1 minus new is the same as 1 over 1 minus 1 over I plus 1. That's exactly what new is. It's 1 over 1 plus I plus 1. That's the discount factor. I'm going to hit this expression over here with a 1 plus I in the numerator and a 1 plus I in the denominator. And what I get over here is I get that this is 1 plus I over 1 plus I minus 1. So that's 1 plus I over I. And recall that the effective annual rate of discount D is exactly I over 1 plus I. So this expression over here is just 1 over D. So this 1 over 1 minus new is exactly 1 over D, and that gives us an easy way to remember this A double dot formula. So now we have our A double dot formula. So our A double dot N I is exactly 1 minus new to the N over D. So the annuity due, the payments start at 0, and you can remember the formula 1 minus new to the N because there's a what in the denominator? A D in the denominator. So I remember that as annuity due. So that's my formula for A double dot and I. Now annuities due are very, very common in insurance studies because when you're paying premiums, you pay your premium at the start of the policy, right? You don't get to pay the premium at the very, very end of the first year of your policy. You don't get coverage for nothing during the first year. So when you're making payments, the insurance company says your premiums are due. So when you're paying premiums, your premiums follow the schedule of the annuity due for present value calculations. Now let's change the script and do the annuity immediate. So what are annuity immediates? Annuity immediates are a stream of payments starting at time 1 and ending at time n. That's a stream of payments starting at the end of the first year. Okay. So here's what our schedule looks like for annuity immediates. So for annuity immediates, we get this stream. Here's time 0, here's time 1, here's time 2, here's time 3, time n-1, and time n. For annuity immediates, you get $1 at the end of the first year, $1 at the end of the second year, $1 at the end of the third year, $1 at the end of the n-1st year, and $1 at the end of the nth year. Okay, so everything's been shifted over by 1 year in the annuity immediate sense. Okay, and so now let's find the present value of this. So what's the present value going to be? So the present value of an annuity immediate We don't put dots over it this time. We just have A bracket NI. And so what is A bracket NI? A bracket NI is going to be a nu squared, all the way down to nu to the power n. And so there's a common factor of nu over here. So this is going to be nu times, if I pull out a nu, 1 plus all the way down to n minus 1. That's just the annuity do formula. So I can plug in the annuity do formula over here. 1 minus nu to the n over 1 minus nu. And now, if I was to multiply this expression over here, take this expression and multiply by nu, if I did that, I'd have nu over 1 minus nu is going to be what? Is going to be 1 plus I over I times 1 over 1 plus I. That's just 1 over I. So the annuity immediate I has what in the denominator? This is going to be 1 minus nu to the n divided by I. And so now we get our annuity immediate formula. Our annuity immediate formula, A N I with no dots, is going to be what? Is going to be 1 minus nu to the n over I. And that's our formula for annuity immediate. So there's a little bit of a difference between annuity due and annuity immediate. Remember, when you're talking about annuity due, the payments start at time 0. Once you remember annuity due, you can remember that annuity immediate is just 1 year later than that. So always remember annuity due as you're trying to remember how you would pay premiums, what would be due to the insurance company if you were paying premiums on some policy. That's why there's a D, an effective rate of discount, in this denominator. These formulas come up a lot when you're studying more advanced actuarial practices, and so it's important to have this formula sort of committed to memory. Thank you very much.